Welcome to another video on smart architectural programming, and we're going to be solving another binary tree problem from the blind 75 lead code list of problems. So in this particular problem, commonly occurring questions, we basically need to open the problem prompt. We need to find the kth smallest integer in a binary search tree, basically, right? I'm not going to read over all of this here because instead of you can read this when you solve this question in particular, but I'm going to primarily focusing on the logical aspect of how to solve this question. So once we're potentially given a tree like this, right, to find what we need to find is that if the value of k given to us is, let's say, 4, right? That's the value of 4 k. So we need to find the value 4 in this tree, right? And the fourth smallest value rather, right, in this tree. So how do we start, right? So we go back, we start from the root node, right? But from the root node we go back to this, and from this we go back to this, because there's a tree. When you're mapping binary trees, you need to remember first it's left, right? You solve the left problems first, then the root, right, and then the right ones, right? So potentially if we go about doing that, we'll start at 2. So we need to create a list, right? So we start at 2, then 3, then 4, right, and then 5. So the fourth value of k should be 5 in this particular question, right? It's a very simple example that I'm trying to explain this problem by, but that is how you will get your answer. But potentially if there is a mixed up value here, let's see if we can find a relatively complicated node here. Let me just create one then, right? So let's use the black color here. So given a node value here, which is, let's say, 4, right? It has value of 3 here, then 1, and then 2. Similarly here we'll have 5, and presumption is they're going to be correct binaries, which means I'll give that explanation. This should be 6 here, sorry, this is 6. Let me correct that. This is 6. The presumption is binary trees must be correct, right? And this is 7, right? So given we have a binary tree like that, first we need to always remember, just as a reminder, that any value from the root node, anything on the left must be less than the value of the nodes left of the root node must be less, and the value of the nodes on the right of the node must be greater than the value on the root node. So given this this understanding that we have here, we need to basically traverse this node, right? So if we build a simple list here, as we were talking about earlier, it's going to be left, we go from 4 to 3, from 3 we go back to 1, so that's the value. We add 1 first, then we cross 1 out, then we add the value of 3, then we cross that out. And remember, this is based on the principle left, then middle, and then right? That's the principle of the traversal for this binary search tree. So then we go to 2, we add 2, we remove 2, then we move back to this is already done, and then this, which is 4, which is the root node, right? If we do this completely on all of these nodes here, then basically we have next is 5, then we have let's say 6 and 7, right? But it's not in order. Then we need to run a sorting algorithm, get this in order, and find the fourth value, and that is not a very efficient solution, if you don't mind me saying so, right? So a more efficient solution to this problem would be using the I think the breadth first BFS algorithm, and within that algorithm we need to focus on in-order traversal basically for this question. Let me write that down. So basically, to do the in-order traversal, we could we move again in that pattern, but we move a little bit differently. But instead of going over some random method, the most optimized method and the easiest method that you can understand is, given that the value we need to identify, k equals to, let's say we need to find the 7th number, right, from this list. So what do? We move in that direction from 4 to 3, 3 to 1, then we minus 1 here, right? So 7 becomes 6 for us. So let me actually use a different color. 7 becomes 6, but then we realize, then we come back here, right, to 3. Then we deduct 3 from this, then we deduct another one from here from this, it becomes 5, and we cross this out as well, like we crossed 1 out. Then we go to 2, cross 2 out, and make this becomes 4, right? Then we go back to the root node here, it becomes 3, right? And then we cross this out as well, right? Then we go back to this number here, and from here we go to here, and we cross this out, then it becomes 2, and then we go back to 6 here, we cross 6 out, and this becomes 1. So our value here is 6. That's the value we're looking for. So from the kth value, as you're traversing this list, you can reduce minus 1 over and over again, and you get to that answer that you're looking for to solve this question. So with that in mind, let's see if we can solve this problem. Let's run our code here, which is basically a simple code to track the values and the movement process. You can take a look at that. Both cases have been cleared. Similarly, if we submit this code, it should be cleared as well. And that's how you solve the kth smallest integer in BST problem in the blind 75 list of questions regarding binary search trees. If you found any value from this video, please like and subscribe. And if you have any questions, problems, please let us know in the comments so we can help you in solving those problems. With that, I'm going to sign off and see you in our next video. Thank you.